Hello dear students, welcome to Tejama YouTube channel. So in this session we are going to discuss about the electric potential due to dipole. In the last class we have already derived the expression for electric potential due to point charge. So what is that? V is equal to 1 over 4 pi epsilon naught Q divided by R. Yes or no? Now sir, what if we have 3 charges or 2 charges or n number of charges? How do we calculate the electric potential? This is due to only single charge. What if we have group of charges? So before going to discuss about group of charges, let us consider 2 charges. They are equal and opposite charges. Let us consider here we have plus q and here we have minus q separated by some distance 2a. So I will write it as a plus a. So from here to here distance is a, from here to here distance is a. I need to find out the electric potential at this point P. Okay, for that I will draw a line here. Electric potential from positive charge is R1. Electric what is that potential from distance from point P to negative charge is R2. Distance from point P to positive charge is R1. This is negative charge, this is positive charge. So what is the electric potential due to positive charge? Electric potential due to positive charge is 1 over 4 pi epsilon naught Q divided by R1. What is the potential due to negative charge? V minus is equal to 1 over 4 pi epsilon naught minus Q divided by R2. So if we add these two, we will get the answer. So total electric potential is given by electric potential due to point charge, that is positive, electric potential due to negative point charge, negative. So V is equal to 1 over 4 pi epsilon naught Q divided by R1, Q divided by R1 plus 1 over 4 pi epsilon naught minus Q divided by R2, minus Q divided by R2. Let us take 1 by 4 pi epsilon naught common. So V is equal to 1 by 4 pi epsilon naught. Even Q is also common. Okay. Into remaining we have 1 by R1 minus 1 by R2. So we can again simplify this by considering a line here. Okay. I draw a line here that is considered as N. So if you extend this to this side also, you can draw a perpendicular here. So let us consider this is theta, this is also theta. The total distance from P to this point, let us consider O, is R, total distance is R. So from the diagram I can write R1 is smaller than R and R2 is greater than R. How much? R is the distance from O to P only. So R1 is R minus ON, okay, and R2 is R plus OM. So what is M? This point. So this distance is equal to this distance, extra ON is there. This distance is equal to this distance, meaning less this much is there. So R plus OM will give you R2, R minus ON will give you, what is that? R1. Now what is ON? Since these two opposite sides are having the opposite angles are having the same angle, so I can use cos theta there. Cos theta is equal to, what is that? Adjacent by hypotenuse. Adjacent is this, base by hypotenuse. Base is ON divided by hypotenuse. Let me write that here. Cos theta is equal to ON by A, ON by A, or in this triangle it is OM by A. Look at the diagram, OM by A. Therefore ON is A cos theta, R minus A cos theta. What is OM? A cos theta. So R1 value, R2 value we have got. That you substitute here and solve. Okay. Okay. So V is equal to 1 over 4 pi epsilon naught q 1 divided by, what is r1? R minus a cos theta minus, what is r2? R plus a cos theta. R plus a cos theta. So simplify this further, 1 over 4 pi epsilon naught into q, r plus a cos theta this side, minus r minus a cos theta this side. So minus into r minus r, minus into minus plus a cos theta divided by this one into this one, r minus a into r plus a, cos theta is there. So a plus b into a minus b formula is what? A square minus b square. Correct, no? So now v is equal to 1 over 4 pi epsilon naught, r minus r get cancelled, q here a cos theta plus a cos theta, 2a cos theta is there into q is there. So I will write 2aq into cos theta divided by r square minus a square cos square theta, because this is r plus a into r minus a cos theta is there. So r square minus a square cos square theta will be there, because it is in the form of a plus b into a minus b, a square minus b square. What is 2aq? Since we know that p is equal to, since p is equal to 2aq, so we can write like this. So electric potential is equal to 1 over 4 pi epsilon naught p cos theta divided by r square minus a square whole square. So this will be your expression for electric potential due to, what is that? The dipole. Sir, what if r is so much greater than a value will be very less. For example, h plus cl minus, if we take, it is a dipole. So r value, if we take at far distance, the distance between plus charge and minus charge is very less. So what happens? A square will be neglected, neglect a square. So you will get electric potential due to dipole as 1 by 4 pi epsilon naught. This will become 0. So p cos theta divided by r square. Look at this. Electric potential due to dipole varies inversely proportional to r square, not r. Okay. Now write it down. Write it down. Done. Now, so how does the graph of electric potential due to dipole with respect to distance varies? Let us discuss about it now. So here we have electric potential due to point charge, and we have electric potential due to dipole at any random point. Due to point charge I have written here, I will write it again. So V is equal to 1 over 4 pi epsilon naught q divided by r. V is equal to 1 over 4 pi epsilon naught p cos theta divided by r square, p cos theta divided by r square. So if you draw a graph of, electric potential with respect to distance for V versus R for point charge, it looks like this, and for dipole it looks like this. Okay, so this is for inversely proportional to r square, this is for inversely proportional to r. Okay, so that is how actually it can come even closer, no problem with that. Like this. Okay, this is about this. Now, sir, what about theta, sir? If you consider a dipole, negative charge, positive charge. The dipole moment is given like this, right? So this theta is taken with respect to dipole moment. This is r, right? So point P, this is r1, r2. This theta is taken with respect to P. If in case theta is 0, if theta is 0, that means P will come this side. That means along the axis. Along axis. So what is the electric potential due to dipole? So cos 0 is 1. So we will get 1 by 4 pi epsilon naught P divided by r square. So along the equatorial, that is, if theta is equal to 90 degree, if you take along this axis here, anywhere, so along equatorial plane or equatorial line, equatorial or perpendicular bisector, okay, cos 90 degree is how much? 0. So we will get 0. That means if we take a dipole and here if we draw a plane perpendicular to it like this, so in this plane or on this plane, electric potential will be 0. Potential due to this one and potential due to this one everywhere get cancelled. Okay, so electric potential along the equatorial get cancelled. So this is called the zero potential region. Okay, this is about electric potential due to point charge and dipole. So the variation of this theta is important. Sometimes they will ask you how does electric potential vary with distance for point charge and dipole. For point charge it is inversely proportional to r, and dipole it is inversely proportional to r square. If you consider electric field for point charge is inversely proportional to r square, and for dipole it is r cube. Okay, so this is about this. We'll meet you in the next session with a few more concepts. Till then, take care. Bye. Thank you.